Okay, number 6 here was use exponential notation to rewrite, and we have a bunch of expressions. Now these expressions, notice they have radicals. So the main thing to understand is that when you have radicals, square roots, roots type stuff, that you're going to have fractional exponents. So A, you have x squared, and then the square root of x is what fractional exponent?
1/2.
1/2. So times x to the 1/2 power. We can add these exponents, or do you multiply them? Add. So you have x to the 2.5 power. And I'd be okay with that. If you put it into improper fraction, that would be fine too. So it'd be x to the 5/2 power. And as long as you have it as a power with an exponent, you'd be okay to go. B, same idea. We'd have x divided by x to the 1/2 power. Since you're dividing, what do you do to the exponents? Subtract them. So this would be x to the 1 power. 1 minus 1/2 would be x to the 1/2 power. C. C would be x to the 1/2 power divided by, what would that fractional exponent be? X to the 1/3 power. We're going to need to subtract again. So when you subtract, you're going to have to make some fractions that have common denominators. So they'd be x to the 3/6 power over x to the 2/6 power. So when you subtract, you get x to the 1/6 power. One more. D. Now on D, all of this good stuff here, the x to the 3rd, the y to the 4th, the z to the 5th, we're taking the cube root of all of those, which you've already said that we take the cube root, which is right there, that you would have a 1/3 power. So that means that all of this stuff is up to the 1/3 power. When you take an exponent up to, I take this exponent up to a 1/3 power, what do I do with these exponents? Multiply them. So that means that you multiply the 3 times the 1/3, so that would just be an x. This would be y to the 4/3 and z to the 5/3. And they're in fractional exponents. They're in exponential notation. We're good to go. Questions there?